Arguably, the most limiting factor of fusion filament deposition is this. The fact that a 3D print can be so easily snapped limits this technique as a tool to generate functional prototypes. However, as you can see, the snapping only happens in the vertical printing direction. On the horizontal direction, there's quite a bit of yield before the part actually breaks. This is mainly due to poor adhesion between layers. If it weren't for this limitation, fusion filament 3D prints would be quite indestructible for a plastic part. In this video, I want to explore the possibility of creating rather simple 3D geometries by bending planar 3D prints. This is a planar 3D print that we will transform. To do this, we're going to take advantage of PLA's glass transition temperature, which is around 60 degrees Celsius. Above this temperature, PLA becomes soft, but it doesn't melt, so it becomes malleable and can be molded and shaped in different ways. In order to bend the PLA, I'm going to use a heat gun. This small heat gun provides more than enough power to soften PLA. After 15 seconds, the PLA can be easily bent into the new shape. I'm using a ruler so that the bend is sharper. As you can see, the PLA cools down in seconds, and it retains the shape. Since I bent it with my fingers, the bend is not perfectly straight, but it will do the job. Once it has cooled down, it can no longer be easily deformed. Not even by using tools. Now I just bend the legs with the shape of a hanger. And I wait some seconds until it cools down before releasing the tension. The same for leg number 2. Works like a charm. As you can see, this is an easy method for producing strong 3D prints that do not need to be that precise to fulfill their purpose. And this is our finished product. And here it is working. And here it is working again. Alright, bye!